Okay, so welcome everyone to the Switch 2 presentation by the first Obsidian cohort, who's composed of Annie, Mina, Saré, Rodrigue, Boao, Ricardo, and Walid. So the title of Switch 2 activity was Monitoring Wind Energy Infrastructures, and the students had to as a deliverable to do a comparative analysis of the monitoring versus non-monitoring scenarios for wind turbine blades based on one choice of non-destructive inspection technology in terms of socio-environmental impacts and mutual benefits in the long term, considering that the wind turbines are located in First Nation territories. So the floor is yours, student, for your presentation. I'm just going to make sure you can share the screen. There you go. Okay.
Isabelle, est-ce que tu préférerais que nous, on éteigne nos caméras juste pour la présentation pour que ce soit plus étudiant?
Oui, on peut faire ça. C'est bon, excellent. Et éteindre nos micros aussi.
Oui,
ça
parfait.
va augmenter le débit aussi. Hein.
Okay, so we will start the event. Thank you for all for joining us today at this first edition of the International Summit of Wind Turbines Blades Recycling Innovations. So we have an interesting program of conferences, panel, and also case study to overview and point out the progress related to cutting-edge monitoring technologies to inspect and predict the wind turbine blades damages. So the main context of this summit is the following. At the decommissioning, a wind farm could be recycled around 85 to 90%, but most components of a wind turbines are reusable and recyclable. A challenge still remains the wind turbine blades. So actually, more precisely, the wind turbine blades are made of several composite materials such as fiberglass, epoxy resin, and which are not fully recyclable and affects the landfill. So other problems could be also mentioned as blade damages, imbalance, ice accretion, downtime due to blade inspection, and also reparation. So in this context, bring several questions to the industry at different levels. We have here the program for the day. In fact, if you go just at the previous one, technical issue, just 1 second.
I cannot share like this.
In fact, I will just say the question. So actually, what could be monitored to assure optimal wind turbine blades lifetime? And what could be reduced or replaced or rescheduled to avoid the breakdown? What are the wind turbine blades life cycle monitoring or non-monitoring scenarios? And what are the impacts, obviously, of each option? So this brings us to the main purpose of this summit, which is the conferences and the panels case study that we plan for you. So the first one will be about the socio-environmental impacts and the benefits for First Nations. Then we will have a panel with the bronze technology monitoring versus no monitoring. And then a conference about how could we increase the wind turbine blades lifespan, and 2 case study about innovative recycling solution or innovative manufacturing solution. So let's start with the presentation of Rodrigue Caron, a socialist, about the wind farm socio-environmental impacts and benefits for First Nations. So Rodrigue, the floor is yours.
Okay. So first of all, it's important in a big project like a wind farm to consider every aspect so we don't get blocked in the middle of the project by social interaction. So 4 things that are important in the wind farm, especially in Quebec, is since we are often in First Nation soil, well, we have to consider their community, we have to consider the environment, the social aspects will be the other citizen, and the economic aspect of a project. So for the social impact, some people are going to consider wind farm as a visual pollution. So you have to consider the citizen annoyance, how much they hate it or if they love it. So it's important to do a survey. You also have the sound pollution. Since it's low frequency sound, they can calls without too much resistance. So it's going to affect how close you are to the civilization. By potential health risks, they're really minor. It's more related to sleep deprivancy or stress when they are, again, too close. And also, again, only citizen annoyance depends on the person if they're annoyed by the noise or not. And if you go more on environmental, well, it's really important to do before you start to do studies on local fauna, like bird migration paths. So you have the least amount of impact with blades as possible. And also people don't think about that a lot, but land animals trails, where you have to study them because often the sound of the blade turning is going to scare away and can affect how the land animal live too. And then you also want to calculate your footprint. So we say it's green, but nothing is really zero emission. You always have a small amount of emission. So you want to make sure it's as low as possible during the construction, the operation, and also when you are going to waste break parts that are going to break. And more on the economical aspect, well, you want to make money, of course. You don't want to lose too much money with your project. So you need to study first the wind energy available on this site. So you don't want to put your windmill anywhere. You want also to look at the manufacturing cost and the operation cost, which we're going to talk later with the monitoring versus non-monitoring aspect. And when we talk about the First Nation, it really englobes all the 3 points I talked before. In Quebec, since the high wind places are often on First Nation soils, you really want to include them in every step. You don't want to treat them like they don't know anything. You really want to explain the bad and the good, so they can take a good decision with you. And if you do that often, since it's greener than the illicit petrol, they're going to accept the project and go forward with it and actually help you. So in the long run, it's really beneficial to include them in every step. So you can make them partner, you can employ them when they have formation, so you have really people close to the windmill to work on it. You also want to respect the land and nature because it's really part of their culture. They're people that really protect the environment, their animals. So you want it to be as green as possible. So this is the environment aspect that really regroup them. And also the social aspect, you really want to help them because often they're in remote communities. So a lot of them are going to run their electricity on diesel generator. So having a windmill for them could be an advantage on being greener. So they're running their town on wind energy instead of diesel.
Thank you a lot, Rodrigue. Thank you for the presentation. It gives us clear information about the potential impacts and also benefits of the windmill. In fact, we will continue with a panel now with Ricardo and Walid, so 2 experts. We will describe the drones monitoring and also the drone non-monitoring. So Ricardo, you own a company in the wind energy in Brazil, and you decided not to use monitoring technologies, neither human resources, and to monitor the wind turbine blades' health. Could you explain us why?
Yes, for sure. So my name is Ricardo. I work in a company in Brazil that we produce wind energy in the north part of Brazil. And, you know, for us, monitoring is very expensive. So it's a very expensive operation. We have 2 ways of monitoring things. One is using high technology to do some monitoring, like drones and, you know, inspection, which are very expensive. You have to invest a little bit on those new equipments. And you can also, or the second option would be to send people to do some, you know, planned maintenance. So in both ways, cost is involved, and our operation, we do not have too much profit. So we have to be careful on when dealing with new, technologies, or in doing planned maintenance inside. So why we think this is not very interesting for our company? The first thing is when you try to use some technology or for inspecting, blades. We think this is those are very complicated objects. Inspecting those. They have curved surfaces. They have multi-layered. They have variable thickness around the material and throughout it. So the materials have different chemical properties. So it's not as straight and forward task. You have to be careful. You have to take many variables into account. Besides, the current testing and inspection technologies, they are not really review hidden flaws or defects in these materials. So we don't trust it for, we don't think it's effective enough and affordable for our situation, for our current situation. Also, when you think about, sending, people, our own personnel there for, doing maintenance, mainly planned maintenance, we think also this is not very interesting. We think this is a very dangerous operation. We avoid sending people over there. We're talking here about, 250 feet high. Blades also have, extend over 150 feet. So those are big things. They are moving. So we also avoid sending people over there. So technicians also need special, trainings. They have to be certified. They have to do, they have to obtain, certifications for working in these conditions. So for those reasons, we think this is not something that is very interesting for us in our situation.
Thank you. Thank you, Ricardo, to give a great image about the non-monitoring aspect. Walid, as a CEO of a major energy company in Egypt, why did you decide to use monitoring technologies? Walid, we don't hear you.
Hi everyone. As you see, we have seen that non-monitoring has some risks and have a serious problems, and we decided to use monitoring because monitoring help us to find solution for these problems. So why monitoring? Why we think monitoring is important? Because with monitoring we can detect small problems earlier, so we can solve these problems before they escalate. So we in this case we will reduce the major faults. So we don't have major faults, we have only small problems, so we can solve these problems easily, and this will decrease the downtime, and of course this will decrease the cost for maintenance. And in addition, we will have healthy blades all the time because we take care and protect our blades regularly. So this will increase the lifespan time of the blades, and also we will have less wasted materials. And this is very important to have a green country and to protect our environment, as we can see in the picture. In addition, when we have healthy blades with long lifespan, also this healthy blades will have high efficiency, so we will increase our profit. And if we increase our profit, we can improve our monitoring techniques, which of course will help us to detect small problems earlier, and so on. In addition, next slide please. In addition, using sensors, we will have a lot of data from these turbines. So we can use this data with machine learning and image processing techniques to find solutions, a lot of solutions, and study this data. This will open new topics in the research area, and when we do research in these points, we will have better understanding of turbine faults. Also, we can improve the manufacture of the turbines. In addition, we will have more jobs for the First Nation, and this is a good point for the society. Next slide. So what we are going to use for monitoring, we are going to use drones. We are going to use drones with different imaging technique. The first one, we are going to use thermal images. And as we can see, when we take thermal images for a damage surface of the blade, like we have in the left picture, the thermal image of it, which in the right picture, can show us this the cracks and the damage in the split. So using drones with thermal imaging technique, we can find defects and the cracks in on the blades. So what we can do next to solve this problem? To solve this problem, we are going to use something called the swarm robots. Swarm robots are a tiny robots that are working in a team. These robots are very tiny, are very light, and they can carry on and move to the top of the turbine using the drones. So these robots can work together to fill the cracks and solve the problems that we have on the blades. One of the problems that we have on the blades is the ice. So we are going to use another technique for imaging. We are going to take 2D images from different views using the drones. Please open the link. Using these two images, we will have a 3D model for the turbine. From this 3D model, we can check our blades to find any problems also. And if the blades have ice, the volume of these blades will increase. So if the volume reached a certain threshold, we at this decision, we will take a decision for removing the ice. We can also use drones to remove ice. As you can see in this video, you can see that, sorry, the video doesn't work.
Sorry, there's a security problem with the video. So Walid, you might continue.
Okay, we can use drones to remove ice using water. This water, we can bring this water if the drones are near the coast. We can bring the water from ocean, and if it's in farm, we can bring water to the site, and this will help us to protect our blades. So as we can see, drones can be used not only for monitoring, but also for repairing and make our blades healthy all the time. But as we can see also, there is a lot of techniques that can be used for monitoring. All of them have their weakness and strength points. So we can say that our technology is the best one, but it's an effective one. Thank you.
Thank you, Walid. It gives us a lot of details about potential monitoring technologies. We will continue now with the expert consultant, Sarah. She will describe us a summary of actual existing techniques to increase the lifespan of blades, and we will receive more details also with her presentation. So the floor is yours.
Hi everyone, my name is Sarah. I'm an expert consultant in collaboration with a Valid and Ricardo's company. And today I want to share with you a couple of recycling techniques that are in use and also summarize the monitoring methods in a nutshell. So as Valid mentioned, there are a couple of online monitoring techniques, but each of them has its own disadvantages. Maybe if I want to summarize and give an optimum solution, we might need an integrated monitoring system, such as the one shown in this picture, to set up all the hardware system on site where the wind turbines are located by locating and installing different sensors in the tower of the turbine, and then using a decentralized software system, we get all the data, and using a data acquisition system, we can analyze the data later, and a self-diagnostic system can be helpful to automatically diagnose the defects on the turbine so that the user can recognize the defect as soon as possible and then do the required measurements in order to have a continuous structural health monitoring system. So as a result, the continuous monitoring is necessary and important in order to improve the structural reliability of the system and also to facilitate the optimal decision related to the maintenance and operation of the wind turbines at the minimum cost. However, using all these monitoring systems, still the life cycle of the wind turbines are around 25 years, and we still need to find a solution how to deal with the waste of these turbines at the end of their lives. There are a couple of very common techniques, such as landfilling the turbines and incineration techniques, but currently in Europe, all these techniques are illegal and the companies are forced to use recycling methods with the waste products of wind turbines. However, in Canada, still the legislations allow the companies to put and dispose their waste to the landfills. So the landfills are piling up, and also the problem with the incineration techniques is that they produce significant sources of greenhouse gas emissions, and these are not environmental friendly. Another recycling techniques that are in use and in practice are the chemical techniques, but the situation and the problem with those techniques is that they limit the commercialization of these products because they use hazardous chemicals, and also they're pretty expensive. The best and most optimum way now up to this date is the mechanical recycling of the wind turbines, but the problem is that we can only extract short fibers from the waste product of the turbines, and also sometimes the mechanical properties of the recycled fibers are not as good as the virgin fibers. Therefore, we need to come up with an optimum technique that help us to recycle these waste in the most optimum and best way possible. That's why we are asking to entrepreneurs to help us finding an optimum solution with this problem.
Thank you, Sachi. This brings a lot of details about the actual recycling methods. We have the opportunity to welcome two entrepreneurs from startups who will bring more details about innovative solutions about recycling. We will start with Bohao. So the floor is yours.
Hello, everyone. My name is Bohao. We are a startup in Quebec who develop innovative recycling solutions. So why do we need to recycle fiberglass material? There are so many advantages. First of all, they are resistant to corrosion. They have really good structural strength. They can resist high heat, and they are electrically non-conductive. So we are reusing the existing material from the wasted blades. The first usage is to repurposing them into big parts, like in the order of several meters. And the second usage is to reprocessing the existing blades into small elements. So for the first part, we are thinking about repurposing into soundproof panel. For example, we can install those soundproof panels alongside the auto routes. We can also develop soundproof systems in your home theater or professional theaters. And also we can use the existing blades to build them into bridges to connected buildings together. This will especially be useful in schools and business area to connected buildings together. And also we can use existing blades and turbine tower to build playgrounds for kids. The material will be very suitable for this purpose. And regarding the reprocessing to small elements, we're thinking about building prefab house using the existing material. You can enjoy your quality time with your family using this type of prefab house. And also, you know, the fiberglass material, it has a shiny finish. So we are thinking about reusing this material to build furnitures, especially in living room or conference room.
Thank you. It gives a lot of example about the reuse of the blades. So now we are talking with Mina about innovative manufacturing solutions. The floor is yours.
Thank you very much. I'm Mina, and in our company, we are looking for new materials that can be replaced for materials that already used for turbine blades, of course. So I think it's the time to welcome to the future by replacing new materials instead of thermosetting materials that already used for wind blades. There's a company that already used thermoplastic resins. They mentioned that thermoplastics have the potential to revolutionize the wind energy industry. I completely agree with them, and they can. In our company also we combine this idea to use and also using hybrid carbon fibers to improve the mechanical strength of the final composite to increase the life cycle. So in the mentioned company, they are National Renewable Energy Laboratory in the American. They use thermoplastic resins for production of wind turbines. And as you can see in their manufacturers, they don't need to change any manufacturing equipment. So it's very easy for them to replace this kind of resin instead of thermosetting resins. And also by replacing this kind of resins, they can improve the structure of the damping. And also they can easily repair the turbines that already used by melting, by using this kind of resins and just a very moderate temperature, and this resin can fill that crack. So we can increase the life cycle of the blades. And also the most important part is that this kind of thermoplastic resins can be easily recyclable. So it's very sustainable method to replace this kind of resins instead of thermosetting material. And also very scientific papers that mention that using only 30% of the carbon fibers instead of glass fibers that already used can increase the can double the fatigue failure resistance and also reduce the weight of the final blades. Of course, it increases the cost of material, but considering the increasing the life cycle, it's more feasible to replace this kind of materials. And so in our company, we combine these two methods. We use thermoplastic resins and also use hybrid of fibers. And here we can have comparison between these two kind of methods and also consider the life cycle and recycling methods. For the conventional methods, we have raw materials and we use manufacture them and assembling them, and then the life cycle is predicted to be around 25 years. And also, we know that by recycling them, the thermoset parts cannot be replaced and reduced. They can most often burned, and so it consume a lot. And also, it has a huge amount of landfill. But in another way, in our company, when you use this kind of material, we can reduce the amount of cost, especially in the assembling part, because by this kind of thermoplastic resin, we can also use this kind of manufacture nearby the set point, so with less fuel energy we consume. And also, since this kind of parts can be very in a small part and they can join together on site, so we can have a very cheaper, low weight parts so they can move very easily. And so, of course, the life cycle should be near to double. And also we can recycle them very easily since we can reuse the extracted fibers. And also on the other way, we can melt the matrix and reuse as a raw material. So at the end, we have very small amount of landfill. So it's a very sustainable method that can be used for the future. That's
Thank you, Mina. This brings us to a final step of this international summit. In fact, I'm assuming that you all have questions about the presentation and also the integrative solution that we bring. So thank you all, expert consultant, to be here. And we will go with your specific question.